Well, 120, some of them are virtual, so they don't get any credit.
Get a real mic. Hello, hello. Mine is, I'm mute. Hello. I think it's out of that. Anybody good with technology over here? Anybody? Do we have any technologists?
I think you're good right now.
Hello.
Is your laptop muted?
Yes.
Yeah.
Is it good now?
All right. Can you guys hear us? Okay, I still hear an echo somewhere, but.
I think that's just the speaker.
Oh, that's a speaker up here. Okay, so back to Squirrel Banking. We're taking our customer transaction data, we're enriching it with the merchant and the customer data, so we can have the enriched transactions and give our customers live real-time analytics on their data through a chatbot. That's what we want to build so that customers can basically self-serve the analytics. So to show you what this looks like, let me quickly get out of the presentation. So this is the chatbot running live. We're going to log in as a user. Our login is not very secure. You just enter the user ID and you're logged in as the customer. So now we want to say things like, hey, things like break down my spending over the last week by category. Now what ends up happening is we're going to send that message to OpenAI. OpenAI is going to tell us what data we need, fetch that for us, and automatically determine what visualization is best suited to show that data to our customer. And so in this case, it decided on a bar chart, if I'm like, oh, actually, I want to see this more like, relative to each other, so I can say, and again, I'm interacting with the chatbot. The chatbot understands what the data is that I'm serving and serves me that same data in a different visualization. I can ask other questions like, give me a number of days, like a couple days, like I'm looking at my spending. 6? So I'm looking at what was my spending over the last 6 days? Oh no, there's a typo. Wow, thank God. In this case, it understood that I'm looking at my spending by day. And so it figured out that the best way to visualize that data is through a time series. Now, what's actually happening? What are we building here? Just to look at. So this is kind of the result. And as you can see, we're going from raw data all the way to custom personalized visualizations of a customer's data in real time. So all of this is, that's why I was asking for the days. This is not a canned demo. I'm like literally live taking these queries, translating them, pulling in the data that is needed and visualizing it on demand. If you look at what that actually entails to do, going back in the presentation, so we're going to look at the quick overviews. There's 2 components to this architecture that we're building. The first is we're taking our real-time live customer data, and we're building a real-time data API that exposes that data in a way that we can query it. The second part is we're then taking that data and exposing it through a chatbot that understands the semantics of the API so it can pull in information as necessary to answer a customer question. Now, why are we doing it in this 2-step process? Well, the reason is that first, we want to enrich our data. We want to process it to make it actually presentable to the customer. And we want to expose it through an API so that we have all the security and all the instrumentation that we get out of APIs. And then do the last step, go from API to chatbot so that we can plug in and have guarantees over the data that is being exposed. Right? And specifically, we want to make sure that the data that we're presenting to the customer is predictable, accurate, secure. We want to make sure that a customer can only see their data, obviously. And we want to make sure that we inject the entire session token for the customer that is logged in. right? So how do we do that? That's a lot of work. And so we're going to be talking about two tools that make this a lot easier for us. The first is Data Squirrel. Data Squirrel is a tool that allows us to take custom data, static or streaming data, and build real-time data APIs. And we're going to look at exactly what that means in our context here. The second tool is called API RAG. For those of you familiar with this whole world of AI, you might have heard of RAG. It's an acronym that stands for Retrieval Augmented Generation. It's basically a very fancy way of saying, how do we tell the chatbot about additional information that it needs in order to answer a customer's question? Right, as you probably have heard, there's this whole LLM crazy thing going on right now where we figured out how to build these really, really large language models that are capable of understanding human language, right? And that's how we were able to say, what was my spending over the last 6 days? And the language model was able to translate that into, oh, the user's interested in the last 6 days, so it's able to translate my relative time period into an absolute time period, right? What does it mean to be the last 6 days? And the other thing is figuring out is exactly what data I was looking for, right? I was looking for my spending data per day, since I was asking for the last 6 days. That's something that these language models are really good at. In particular, for this demo, I'm using an out-of-the-box OpenAI GPT-4 model. This is not fine-tuned. There's not much going on. I can show you the prompt. It's literally 5 lines, right? We're not doing any customization. The customization comes from how do we get the data in there that we need for this large language model to return what I'm asking for? And that comes from the API. So by retrieval augmented generation, what we mean is, how do we give the LLM an understanding of where the data is so that it can tell us, hey, fetch this data and return it to the customer, because that's what the customer is asking for. And that's this component, the API RAG. It's basically a RAG, retrieval augmented generation, that works for APIs. And we're going to look at what that means exactly and how that works in just a second. But just so you have an overview of the whole architecture, 2 steps. One is, how do we go from raw data to enriched, cleansed data that we can serve through a real-time API? Step 2, how do we take that data from the API, feed it through a chatbot to the customer so they can ask arbitrary questions against their data, and we return the data to them. We believe in particular the last part is going to be the way that we will be serving data in the future. I think pretty soon we'll see that the days of building, handcrafting analytics dashboards for customers is going to be over. We're not going to have to write all these individual views for all the various types of analytics you want to do. We're going to give the user a prompt to say, hey, what are you actually interested in? And the user can tell us. And the user, like I showed in the demo, can tell us, actually, I want it visualized differently. I want a different time period. I want it aggregated differently. They can tell us that in language, so we don't have to build these intricate UIs to serve that data to the customer for these last mile applications, which is going to be particularly useful for customers that are not technically skilled, right? So we're looking at, like, if you work for a bank, we're talking banking customers. If you work for an organization that has any kind of customer that is not a non-technical customer, this greatly lowers the barrier to adoption of data-driven products. So much for the overall pitch. Now let's dive into what exactly are we doing for each of these components. So the first thing we're going to talk about is, how do you get from raw data streams, so these could be Kafka streams, these could be Kinesis streams, this could be data that gets into an S3 bucket, any kind of data that arrives raw. And I'm sure if you work for a large organization, you have hundreds of these data sets sitting everywhere. How do you take that data and build a real-time data API that you can expose to a customer, meaning that satisfies an SLA, that is robust, that has low latency, that is scalable? How do you do that? Well, traditionally, you would have to do a lot of things. You would have to figure out how to pick up the data, process it, store it in a database, and then serve it out through an API layer. With Data Squirrel, you can do the whole thing in a simple step. Data Squirrel kind of acts as the operating system for your data that allows you to abstract away this multi-step data pipeline that you have to build behind a simple SQL script where you define the logic of what you're trying to do with your data, and an API specification that defines how you want to expose the data, right? Like, think of it sort of from a web application perspective. For those of you who've been building web apps, right? It's sort of the model view controller paradigm of, you have the model and the controller of what you're trying to do, And then you have the view, the API that exposes it to your customers, or internal or external. What Data Squirrel then does, it takes those two artifacts, it builds the entire computational DAG of processing. So it understands from source, what are your data sources, to the sink, namely the API, what you're trying to compute, and it then compiles that onto a data pipeline that executes that logic most efficiently against Flink, a database, and an API server. So that you as a developer can focus on the what am I trying to do, and you don't get bogged down by all the this is what I have to do to make it happen. Correct, yeah, that's how that, and specifically if we look sort of behind the scenes of like, what is it that Data Squirrel orchestrates for you, you can kind of break it down into the individual steps here. You can see what Data Squirrel does, it compiles an end-to-end data pipeline that manages the data access, that manages the data validation, that maps obviously the logic of how you want to process the data, that maps the schema between the input data, Flink, and the schema in your database. It writes to the database in a way that is optimized for real-time processing, but batching up where necessary. It then installs the right data model in the database to have a sink where you can write to. It makes sure the right index structures are installed based on the API query access patterns. It makes sure that queries that are expensive are materialized ahead of time. It makes sure that you map the API access points onto the right queries in the database and expose the whole thing through a persistent result set. So all these components are taken care of by a compiler, right? In a way, the way you can think of Data Squirrel is like, if you write in any higher level language like Java, Python, JavaScript, right? You don't have to worry about all these low level details of what variables do I set in my CPU registers, how do I access data on the hard drive, what interrupts do I set on the bus in order to fetch a certain offset on an SSD. All of that is taken care of by the operating system, right? Like you usually implement against the library that abstracts all of that from you. You just say file handle open and then you go, right? All that low level stuff we don't have to do anymore. And Data Squirrel does the same thing for data, right? It gives you an integrated perspective, an operating system of sorts that abstracts all that low-level stuff you currently have to do, all that Avro data mapping, all the how do I synchronize my physical database schema with the schema that I have in Flink. All these sort of things are taken care of by the Data Squirrel compiler for you. So what do you actually write in Data Squirrel? Let me show you the use case that we have in this particular instance. So this is the entire implementation of the use case I just demoed in the chatbot. What we do up front is we import the data that we want to have. Data Squirrel abstracts data sources and data sinks and makes them declarative. So that allows you, yeah, sorry for you guys sitting over there. It's a little hard to see, huh? Data Squirrel makes it easy to define what your data sources are in a declarative format and then import them like you would import a function or a library in software. Right? We think of this as a dependency in your code. And then you can define what you want to do with the data. So in this case, we are importing a stream of merchant data and a stream of card assignments. So Squirrel Banking keeps track of which credit card is issued to which customer with the card assignments. We are distincting this information so that we get the unique most recent card assignment and most recent merchant. And then we're doing this big join here. This is our enrichment. We're taking the customer credit card transactions. This is the part here, the from transactions T. These are our credit card transactions. And then we're saying, please temporarily join that against the card assignment and against the merchant data so that we can retrieve the customer and the merchant that was part of the transaction at the time that the transaction happened. One of the things that Data Squirrel makes easy for you is to write temporally consistent logic. Right? That's one of the things that's really tricky when you do stream processing, is that you're dealing with data that changes over time. Right? So when you do a join, how do you make sure you join the right things with each other? Right? Because data might arrive out of order. Right? Like ideally the data arrives immediately, but as you all know, if you've worked with any data system, that's an ideal state, but Kafka can fail, your database can fail, right? Things can arrive late. Sometimes you have an outage, sometimes there's some kind of operational maintenance. And so to account for that, what we do is we keep track of when the data has arrived so that when we do joins, those are temporally consistent. And Data Squirrel makes that really easy by giving you a specific join type called the temporal join. And then after that, it's pretty straightforward. What we're doing is we're doing an aggregate by category. So we're doing, give me all the customer transactions and then group them by customer ID, the week, and the category. And down here, we're doing it by day. So similarly, by customer ID and by time of day. So this time, no category because we're aggregating everything by day.
Backend data sources, are those data sources? What's streaming data?
The underlying data sources are streaming data sources. So that could be a CDC stream out of your database. So it could be a SQL, like a relational database. It could be a Kinesis stream. It could be a Kafka topic. It could be an S3 bucket. Right? Some people, like, still pretty popular to do is streaming by writing a file every 5 minutes to an S3 bucket. So it could also be a static data set, right? It could be iceberg tables. It could be pretty much any source that Flink supports, Data Scroll supports by extension.
Not to jump the gun, maybe you can address this later, but when you're doing your point, does it itself figure out how to join this portal? Because it can be different from the data stamp on the packet versus the data stamp on the data itself.
Yeah, so one thing that we do is we keep track of the event time. So when the event originated, and we map that onto the Flink watermark. So Flink has a concept of watermarking whereby it doesn't process data as it arrives. It actually keeps track of when the data originated, and it uses a watermark to indicate when you have seen all the data that should have arrived by that time, right? And so that allows you to do what you're saying, namely to say, hey, I don't have immediate guarantees of how data should be mapped. And so I want to make sure that this is still temporally consistent.
At that event time, let's say there was some outage. So whatever, banking system is catching up. Oh, we missed the last hour. Let's publish the last hour of transactions. So now your stream, the event stamp might be now, but the actual transaction is not whatever, hour ago. Is he smart enough to know the attributes of that?
Yeah, so this is actually one thing that you would configure in your sources is you would define what the timestamp is that you want to use as your authoritative timestamp, right? So in your case, you could say, okay, like we use the originating event time. Now there are a couple of considerations. So now we're getting very deep into the time element of it. But just to say real quick, if you don't have much predictability on your timestamp, we generally recommend that you use a predictable timestamp like a Kafka append log time or the modification time of your S3 file, and then handle very late arriving data in the actual logic of your aggregation. So one thing that we would do in that case, like if you have very late arriving data, we would actually update the logic so you keep track of the bucketing by the event time in addition to the timestamp that you use for event progression. But that's a little more advanced. Oftentimes, you can just get away with defining the actual timestamp and defining a watermark that says, here are the guarantees that I'm getting, or using something like Kafka, where Flink automatically extracts the watermark from the Kafka topic and does it in a way that's sort of intelligent because it knows the partitioning of your topics.
Just review the definition of watermark. I understand, but maybe there should be.
Yeah, that's a good. So one of the really tricky bits in stream processing is knowing what is the current time, right? Like if you think of like querying a database or a data warehouse, we have this intuition of when I write a query, I get sort of the result of that query at that point in time that I'm running the query, right? Like we have sort of a snapshot of data, we run the query, and then we get the results. In streaming, that's not clearly defined, right? Because if you have multiple sources of data, they all might be running on a different clock, so to speak, right? Because one might be 5 minutes behind the other. And so a way to synchronize is to define a sort of watermark, which means you basically think of it as like a metronome that gives you a beat of what the actual time is. And so there's different kinds of strategies, but oftentimes what you would use is a watermarking strategy that says, hey, if you see a timestamp X, we can assume that you have seen everything up to X or before X, right? If you have some kind of an ordering guarantee in your data, right? So the data might be late, but if you know that the data is ordered, right? For instance, in a Kafka topic that is guaranteed, then you can say, oh, I'm just going to use the last timestamp that I've seen as the watermark so that I have sort of a lower bound on what the actual time is. And that's how you can advance processing and data streaming, is through this notion of watermarks. With Data Scroll, it keeps track of all the watermarks through your processing. And one of the things that it does as well is it moves all the timestamps through as well, so that it will automatically be able to determine when we do a spending by category, for instance, here, we're doing an end of week of time. So we're saying aggregate up to the end of the week because I want to have a week-long aggregate. Data Squirrel can figure out for you that this is the timestamp, and therefore I can aggregate this in a time window versus having to compute this fresh every time you query. Because I know that once I'm at the end of the week, so once my watermark has hit the end of the week, I am guaranteed that I will not see any data prior to that, so I can pre-compute that aggregate. And so those are all these kinds of tricks and neat little things that you have to kind of be aware of when you do stream processing, is how do you deal with time? How do you deal with time windows? With Data Squirrel, we're trying to make that easier by allowing you to write your logic, how you would write a database query, and then inferring what the timestamps are, inferring what the right time windows are. So this is something you don't have to actively think about a lot. So let's go further down here. Then we have the other things we do is we define two queries in our Squirrel script for how we want the data to be queried. We query it by category, by day, and by transactions. And so Data Squirrel supports this notion of basically inline query definitions that we can define here, which get mapped onto the API, which I will show briefly here. This is how we then expose the results of our Data Squirrel script in GraphQL. Right, so we can basically map each of the tables that we defined onto an endpoint, and we can expose, we can map it onto the data points that we want, so we have full flexibility of structuring and defining our API. And Data Squirrel figures out all the mappings, right? It figures out, oh, I need to cast this to a string, or I need to cast this to an int. It figures out how it maps the various tables so that you don't have to write all this object relational mapping and all this kind of code that you have to write to plumb it all together. We can do that all for you and map it onto the database. In addition, we can figure out what actually needs to be in the database to serve these queries and optimize the database schema for you. Because behind the scenes, what Data Squirrel does, it compiles all these artifacts that you need to run your data pipeline against the underlying engine. So Flink, in our case, we're using Flink, Postgres, and a Java GraphQL server. You can also have this generated, yes. So often when you're in development, you actually wouldn't write this. You would write your Data Squirrel script and have this completely generated, and it will generate basically the full GraphQL, like all of it. And then you would go in and prune it out because nobody wants to write all this stuff, right? Like you're just going to want to have that generated, and then you can go in and say, oh, I don't actually want to expose that field. I want to have a different data type here or things like that. So with Data Squirrel, this can be completely generated for you. And then as you head towards production, you would simplify this and make this fit to your actual API requirements. Sure.
How do you do the data integration of customer needs of data sets? Is that in the Data Squirrel script?
How do you do the integration of the sources? Yes. Yeah, so all this logic of like, how do you clean your data? How do you enrich your data? This would happen in this logic, right? So in this case, we're doing a pretty straightforward join, right? We're basically saying join the merchant data based on the merchant ID. So we're kind of making the assumption very explicitly that we have the same merchant ID in the credit card transactions as we have in the merchant data. Now in the real world, as we're all painfully aware, usually it's not quite as straightforward, right? Like there's different IDs that are being used and you have to map things back and forth. You can do all this in SQL and you can actually express it very simply because oftentimes those tend to be just intermediate joins, or you have additional data where you have a custom function that maps one ID to another. Oftentimes, you have like different timestamp formats, right, that you need to parse in a certain way. You can do all that in the SQL code. So one thing that Data Squirrel makes pretty easy is you can import custom functions as well. So you can have arbitrary logic for how you want to process your data that you can include. So if you have existing functions for cleaning data, you can import them and use them in here.
Like you do type stuff.
Yes. So this is the part, so far we talked about how do I go from my real-time data sources to a real-time data API, and how do we make that process really simple? Now you can use that data API, directly and give it to your front-end team and say, hey, here's a new data-driven feature. Please integrate that into our app. Or what we're going to be talking about here is how do you automatically give customers access to that data so they can basically self-query for these data-driven features. And so the other part that we will be talking about, I'm going to go back to this, is the API rack piece. So how do you take that real-time data API and map it in such a way that you have a chatbot that can access the data, do it securely, and serve that data to the customer however the customer is asking for that data? The way that works is API RAG is a library that you can include into your server application. So you write a standard web server application, Spring Boot, Node.js, and you give it a JSON file that maps it onto your API. Quick disclaimer, DataSquirrel can generate that JSON file for you automatically, but if you have an existing API, you can write this manually yourself. It's basically a schema layer, and I'll show you an example in a second, that explains to the LLM basically what your API looks like and how it should be queried. And now the process flow is as follows. A client asks a question, so the customer comes in like we did and asks the question of, please break down my spending for the last week by category. That question gets forwarded to the LLM for question analysis. So we forward it to the LLM and say, hey, this is the question that the customer is asking. What data should we fetch in order to best answer this question? And the LLM will respond with the API call that we need to make in this specific format. One of the things that API Reg does for you is encodes that format in such a way that you get a constrained response out of the LLM. So for those of you who have played with LLMs before, you know that one of the great things about LLMs is they're very creative in probabilistic models. For software engineering, that's not so great, right? If you get a difference response every time you run something, there is a high likelihood that you don't get good data out of it, right? And so when you're trying to make an API call, you want to make sure that you have validated data, right? That it matches the API signature. You don't want a creative API call, so to speak, because obviously the API is going to be very stringent about what data types it accepts and what the API call should look like. And so what API Reg does is it enforces a schema basically against the response of the LLM so that we can guarantee that it's a valid API call before we then make the API call. The other thing that API Reg does for you, it injects the user and security context into the function call. And that's really critical. We never expose the security context to the LLM. Right? So we never give the LLM the ability to query arbitrary data. We always make sure that the security context is hard-coded outside the context of the LLM. Again, that's to guard against the hallucinations and the sort of arbitrary results that an LLM can produce, because you don't want a nifty customer to do prompt injection and figure out what all your other customers are doing, right? Like that is sort of something you really, in particular for squirrel banking, right? That would not be a great call from the regulators to be like, hey, we have a major data leak because your LLM went a little berserk on you. And so we do that by injecting the security context and constraining the API call so that we are guaranteed that the data is within the security sandbox that the customer or that the client initiated, right? So this would be the auth token that the client used to authenticate themselves against the API. Once the data comes back, we basically say, hey, this is the data we got. Here's the question the user asked. How do we best represent that data to the user? Do we do a summary? Do we do a table? Do we do a visualization? And again, API Reg gives sort of the infrastructure and the structure around it so that the LLM responds in a way that we can then visualize the data. Right? If you remember back to the demo, I was able to say, hey, can you please show me that as a pie chart? Right? So the LLM was then able to interpret that as the data that I just presented as a bar chart needs to be visualized differently, and it responds in a way that we can interpret so we can visualize the data to the user. So this is the basic flow of API Reg. What's really nice about this model is that it's incredibly flexible. You can use this against any API that you have. Right? Like this could be an existing API, this could be a new API, it doesn't matter. You can use this against any API. You just have to annotate it, and we'll look at that in a second. The second thing is it works against generic LLMs. Like you don't really have to do any fine-tuning to build a demo. You can use a generic out-of-the-box LLM to get this started, and you can build a demo incredibly quickly, and then, then work on fine-tuning the LLM to your specific use case to build a more targeted chatbot for the particular type of application you want to build. Oh yeah, and then of course at the end we return the response. The other thing that API Rec does for you is it also has a lot of features around message preservation. So one of the things that you would want your chatbot to do is have a memory, right, of the interactions you've had with your customer. Now, with Data Squirrel, it's incredibly easy to build data pipelines that are not just one way, meaning you have data, you consume data, and produce an API. We can also actually build the full life cycle of an API that also ingests data. So in our case, and this time I'm going to demo the part that is going directly against the API. So we looked before at the chatbot, right? So the chatbot, as we just presented, goes against the LLM and goes against the API, figures out what the best results is and returns it. You can also go directly against the API. And here I'm using a tool called Graphical. It's basically, it's like an IDE tool for GraphQL APIs that allows you to quickly inspect and run queries against GraphQL APIs. And so what I'm doing here is I'm running a query where I'm asking for customer to, what they're spending by categories. And you can see the data that comes back, right, is that structured data that we just visualized in the chatbot. I can also look at the customer chat messages. And so here you can see the messages that the customer has sent so far against the chatbot, so that I can go in, just to kind of demo this feature, I can go in and refresh my page. So I'm like, I logged out of my session, right? Like this is a completely new session. I'm logging back in and I'm asking, I'm basically asking it to retrieve the memory, and you can see that it has the full session context still preserved. So not only does that allow you to quickly go back in history and answer related questions, but it also allows you to build up a profile of your customer so you can build more targeted experiences to that customer that allow you to not only be smart about what the customer is asking, but also be personalized to the customer over time. Right? As a customer interacts with this chatbot, it can learn the kinds of questions the customer wants, the kinds of preferences the customer has. And with the API, you can basically consume all that data and process it asynchronously in Flink, because that's what's happening behind the scenes is we're running this data through Flink, analyzing it, and then feeding it back out through the API. So all of these things are incredibly simple and easy to do, because all this requires in Data Squirrel is this. Right? This is all we have to do to say, hey, import the chat messages from the API, and then process them and return them as customer chat messages. Right? That's all we have to do to basically support mutations and preserve the history of the data over time. So to kind of wrap up and summarize, we looked at, let me go back to, we basically looked at the problem of how do you take custom data, or data that you have in your organization, and expose it to your customers through an interactive chatbot experience that allows the customer to retrieve the data that they need, visualize it in a way that makes most sense to that customer. And we do that by separating the problem into two pieces. First, how do we build a real-time data API that can take the data and expose it in a way that is scalable and available in real time, and then use a tool that allows us to then serve that through an LLM dynamically to the customer. And we looked at two tools, one Data Squirrel, that makes it really easy to go from your data sources to building real-time data APIs, not only from external data sources, but also capture data internally like we did with the customer's chat messages. Gives you a real-time GraphQL API and abstracts away all that low-level plumbing that you have to do to integrate Flink and the database and the API server. And the second piece we looked at was the actual server component that served that data through a LLM chatbot experience to the customer in a way that's secure, that's predictable, and that's most importantly targeted to the particular customer and use case. And all these things you can do now with a lot less code. Like the entire code that we had here is about 20 lines of SQL, the GraphQL API specification that, like you said, Data Squirrel can generate for you, you can fine tune. And then, oh, I promised to show you the mapping, so that's the last piece, is this JSON mapping that basically gives you the ability to map individual function calls onto a semantic description that the LLM can understand and map to. And you can see here, our safeguard is, in this particular instance, the context that we define, where we say this is the context that we're injecting from our authentication context, right, the customer ID, that is outside the scope of what the LLM can see, right? So the LLM can never overwrite the customer ID, and thereby we can guarantee that all of our calls against the API are sandboxed to a particular customer. All right, that was a lot of stuff. So questions?
This was what confused me earlier. So I think I understood that you write the API specification, right? That's what you start off with.
Here, yes.
But then you still write this sort of SQL joins yourself, right? Or is that generated?
No, in most cases, you actually do it the other way around. Like you start with this. Like you usually start with the, what do I want to do with my data, right? Like you start with the, what data do I have? How do I want to process the data? And what data do I want to get? Then Data Squirrel will generate this part for you. It will generate here, like you can see that these query endpoints map exactly onto the tables that we defined here.
So you generate the API from tables that we know.
Yes. And then,
Think of the sort of JPA library where
yes, and you can do that as well. Like you can also say, let's say if your PM comes to you and says, here's the GraphQL API that the front end team needs, please, build to that API. You can start with the API and then write the SQL to the API. You could also do it that way, right? So you can kind of go both ways depending on what makes sense for your particular use case. Depending on if you know the result, then you start with the API. If you know, hey, I'm trying to like take these 3 data sources and build some kind of customer aggregation, you usually start with the data sources. You build out your tables, and then you have Data Squirrel generate the GraphQL piece for you. And then you go in and kind of prune it out and do the fine tuning so that the API looks like what you want it to be at the end of the day. Any other? Yes.
So your descriptions is what you feed to in the JSON file is what you feed to the LLM so that it can interpret what you're asking. Or have you played around a lot with how to phrase those to get it to work? Like for instance, we asked it what was the last thing that I asked you. You had to have figured out that, oh, I'm not asking for an API query.
Yeah, so there's 2 pieces to this. There is the element of what are sort of what's kind of the data that we're exposing, which is this piece. And then the other piece that you define in your server, when you invoke the API rag library, the other piece that you define is this prompt here that kind of gives you sort of the context for what you want it to be. So in this case, we're like, hey, you're, how like in prompts, you have to be like all specific. You're a helpful customer service representative for a credit card company, yada, yada, yada. And then one of the things that we found to be very helpful is to say you do not provide general answers. That helps guard against the LLM just making stuff up, right? Because that's one of the things that you want to avoid is when the customer asks, I don't know, how much money does President Biden make in a year or something like you don't want the LLM to be like, well, I don't have that data, so I'm just going to make something up. So we do that, and then the LLM will basically say, hey, I don't have that data. I don't know how to answer this. The other thing that we found very useful is to be very specific about the results that you want the LLM to produce. That also constrains it a lot. And finally, in the JSON, it's actually, in the JSON, it's really about it's just about being specific about what a specific API call returns. And that's mostly it, because one of the nice things is that the LLMs are now being trained on this type of data. So you're actually benefiting from fine-tuning inside the LLM themselves, right? The LLMs are trained on understanding, like we map this basically onto a function calling definition that gets passed to the LLM, and the LLMs are already trained on this specifically. So we are benefiting from the fine-tuning that OpenAI, for instance, is already doing on their models to get pretty good answers back. Right? Like you will still see an fortunate/unfortunate in this demo, it didn't come up, but like 1 out of every 20 or so questions that I ask, like you get something weird coming back, like something that was malformed, malformatted. So we're still, API reg is still a new project that we're working on. So we still have to do some post-validation where we look at the result and say, hey, that's not actually the schema that we're looking for. So there's some more work we need to do there, but I am quite honestly already surprised how well it works just out of the box. Right, and I should mention that the example and a bunch of other examples are in the API rec repository. So if you guys are interested, check out the two GitHub repositories. This is all open source, by the way. So you can use these tools to build real-time data APIs. You can use these tools to build LLM chatbots, and just kind of go to town on the example. Try it out yourself. Try playing with the prompts. Right, you can have your customer service representative embody all kinds of different personas, which can be fun. But you'll also see kind of as you play with things, like as you look at the examples, you can see where we were very specific. For instance, in the timestamps, we would say things like, hey, this has to be an RFC 3669 or whatever it is, compatible timestamp, right? Like that you want to be very specific about, because you don't want the LLM to just kind of come up with a timestamp format for you, right? But otherwise, you'd be surprised if you look at the examples, there is not a lot there that we had to do to make it work.
What are the alternatives? What was the?
That's all right. Did you have to create a function for every single question you got? Like ask a very specific query for how much money is going to last week or like a period of time.
Yeah, so you want to be pretty specific in the kinds of API endpoints that you expose, and that's kind of how we map it. The LLM can do things like it can combine different function calls to like figure out what the results should be. But you want, I guess, depending on your use case, if it's an external customer-facing use case, you likely want to be pretty constrained in what you expose, right? Because you don't want there to be a lot of confusion in it. But you can be pretty generic, like you can, like in our example, right? Like we do like spending by category, spending by week, spending over time. Like the LLM is smart in figuring out relative timeframes, right? So I can say things like, give me my spending in the 2 weeks before New Year's, or give me my spending around New Year. Like it can like do all this kind of relative timestamp interpolation. It can do things like understanding if you're interested in particular categories. So I can ask like, give me all my spending on food, and it can figure out that this is restaurants and groceries and things like that, right? Like that's the LLM is really good at. More advanced, like you don't want to use the LLM for things like actual computation, right? Like LLMs are not great at like summing up numbers or aggregating them by something, or like doing any kind of higher math type of stuff, right? Like they can do basic math, but you want to push that into your API. So anything that requires anything that require math, so to speak, my advice would be put that into your API, and you're going to have a much higher guarantee of presenting accurate data to your customer.
Like what's the standard deviation by electric? That's from the API.
Exactly. Yeah. Exactly. If you want to do like, give me a 2-student t-test over this, that, and the other thing, like those kinds of things, you would want to actually compute with like actual like math, right? Like in the API. And that's the kind of part that data scroll makes really easy for you, right? Like you can write all that math all day long, call all kinds of math functions in there, and then have the LLM be mostly the translation layer. I think and this is just my take on it, but having played with LLMs a lot, I think the really sweet spot for LLMs is being that translation layer on the interface, right? Because that's where we're currently struggling, right? Like like if you work at a bank, right? Like you can produce probably 2,000 different data types of analytics for your customers. The problem is you can't present them with 2,000 different screens that they need to look at through a menu and figure out where it should be, right? That's simply impossible. So I think the biggest value for LLMs from a data perspective is bridging the last mile, right? Giving the ability to basically just put a ton of data out there, and then putting an LLM layer on top that basically acts as almost a personal sort of concierge for your data, right? Like think of it as like a switchboard operator. You just call in and be like, hey, I am interested in how much money did I spend at Starbucks over the last month, right? And the LLM goes and like, oh, let me translate that to a query for you, fetches the data and brings it back. Whereas currently, and I don't know what bank you're with, but that would be a really hard query to ask right now, right? Like you'd probably have to do it manually, go through your transactions and filter them out. That's where I think the LLMs will add a ton of value is allowing us to bridge that last mile from we can compute a lot of data-driven features, but how do we give them to the customer in a way that's meaningful to them? And if you think of like this being integrated, for instance, into a customer service or into customer help, like it can be tremendously valuable, right? To cut off 80% of your support calls that are usually just like somebody calling that has some questions and they don't know where to find the answer. And that's where the LLM can be tremendously valuable. Yes.
So you, like, I'm thinking of like my mom going to her bank, like trying to figure something out. Very lovely lady, not
Right.
she's not gonna know like where to speak, like even know what category she's asking. You would have to like present that to like they're not even aware that categories exist. Like you knew that when you typed it. So like you would almost have to give them like a metadata catalog, right? Like how does that work?
Yeah, our goal really is to make the LLM do that for you. Like if let's say your mom uses this chatbot, right?
They should all ask like what can I ask for?
Yeah, I mean, most often when your mom goes to the bank, she probably has some kind of problem she wants to solve, right? Like she probably has something in her mind about, I don't know, like how much am I like, how much money am I making versus how much money am I spending, or like whatever the thing is that you have in your mind. And so that would be a starting point of like asking the LLM, what is the thing that you want? And then if the question is very vague, the LLM can guide you based on its understanding of the data that's available to a question that is relevant, right? So the LLM could say, it's interesting, like you seem to be interested in your like money in versus money out. Do you want me to present that over the last year, last month? Right? It can ask those questions and can clarify, and then your mom can say, oh yeah, I was interested actually over the last week because I'm thinking about buying X, and it's this expensive. Do I have that money? Right? Like, and it can ask these kinds of questions and ask like more as a financial advisor. So our goal is not to expose a metadata catalog or anything of that nature, where we say, hey, here's like the 5,000 questions you can ask, but more like, hey, what is it that you need? And then hopefully guide you towards a thing that the LLM can then translate to an API call and say, oh, here's the data that you need for this, and give that back to you. I think that's where this technology can be very valuable.
I mean, it seems.
You go first.
I just meant,
No, you can go right after.
Is this like using the API right and the scorer is gonna just eliminate what is the LLM is already pre-trained already and just use the data to provide the LLM to work with it?
You mean, can you train the LLM on the data?
No, it means like if you're using the API right and the scorer, is the app only use the data that we provide, but not using the data is trained on the LLM?
Yeah, the LLM really just acts as a translation layer from human to API, so to speak. Right? That's really all the LLM does. Like it doesn't actually, and this is, I think, a key element here, right? Like you see a lot of approaches to LLMs that try to bring the data into the LLM, but for lots of data, that's just not possible, right? Like you can't train an LLM on your customer's credit card transaction, right? Like that would not be viable. And so this gives you a nice separation between the two. All right, last questions, and then we'll have Tim go up.
So, to me, the big thing here is you're going into your SQL database, you're not restricted. You're only specifying that you can, generate this API or your all the data sources for your data world.
Yeah.
So you're saying, I only want you to know how to get this spending query or a revenue query. And you're just only opening those up to the LLM. As opposed to other solutions might be like with LangChain. If you have to build the rag on LangChain, you want to get a database, put that SQL connector, but then it like opens up the entire database.
Yes.
You might say, show me the, but what you're saying now to answer the other question was, you don't want the language model to go and fish everything out. You're saying you're
Especially
losing.
you gotta put some on the internet.
Yeah.
It's just gonna take your stuff and
Yeah.
use it for their own people.
Yeah, LangChain is great if you're doing something locally, right? And you can safeguard against that simply by constraining the space of input. But if you wanted to anything like a customer experience, anything that touches, like anything that's exposed over the internet, you don't want that to be generating SQL that goes against your database, right? Like that's, like if you guys, whoever's old enough to remember the old SQL injection stuff, right? Like where you just do semicolon, truncate your data. Like you have that, but on steroids, because now you have a super intelligence generating your SQL injection prompts, right? So try to guard against that, right? Like try to guard against a machine that is trained to generate like arbitrarily complex code, and you're trying to figure out whether or not that code that it generates is safe to run, is impossible, right? Because SQL is Turing complete, so you have no chance of actually doing that. And this is an approach that allows you to do this by not only constraining what the LLM can do, but making sure that the security context is always injected. Because that's the other thing, is like, well, you generate an arbitrary SQL query. How do I know the LLM actually put a where customer ID equals X in there? And not where customer ID or like, how do you validate that? It's impossible. So that's kind of why we believe API RAG is a way to take LLMs to a whole new domain of data that you simply cannot expose otherwise, because it gives you that constrained input.
How does the binding work between the LLM and your metadata? I was like, I know category of expenses, but maybe they have different names, where I have a completely arbitrary name for a category, but that does map to a bunch of human words someplace. Where does that happen?
Yeah, so this happens in this mapping file here. So you can do like you have a description of what you do, and let's say you have an input that is an enum with values that make sense in your domain, but nobody else uses those terms. And in those cases, what you can do is you can specify them here and then give a description that says, we call it dog, but it's actually a cat. So, call it cat to the customer.
So you're just feeding this JSON file to the LLM, like so that it understands.
Yeah, so API RAG takes this and then transforms it to make sure that the customer context and the security context is validated. So it does a little bit of additional processing, but not much. Like if you look at, the nice thing of API RAG is literally the entire code base is about 1,000 lines of code. So in an afternoon, you can read the whole code base. It's not a very complex solution, like compared to like LangChain or something like that, right? Like where it's pretty substantial. This is actually pretty simple because we are mostly just translating to the LLM and using the pre-trained LLMs that understand this kind of structured data. And that gives us most of the mileage.
So does this JSON document contain how graphic query should look like? And then
Yeah, exactly. That's down here. Yeah, so you can see this is actually the literal GraphQL query that maps these data points onto this query down here.
And how does it understand how? Okay. So
We can.
How does it understand how to create the GraphQL query?
It's literally right there. Yeah. And we can have more questions after. Like I'm also happy to show you a couple of other examples. It probably is more obvious than what it actually looks like.
I have 5 minutes left. I do have to shut down the facility.
Oh, okay. Then you need to go.
But if people want to if you want to do the sidebar in the other room or in a private room, you can ask questions and.
Yes, we'll do that.
Everything's being recorded. At the bar.
Exactly. Or you join us for drinks after and we can go real deep.
Data scroll after party.
Data scroll after part,
One
exactly.
last one. How does the auth work? Like there's a sample token, like a token given to the user, and it's active.
You can configure it in the server however you want. It's completely flexible. It will pass it right through.
Thank you.
Of course. Thank you guys.
Oh, yes, the mic.
Mike. And then I'm gonna do this now. Okay. Oh, if I turn that one on, it won't like that. Okay, hold on. Trying to get too fancy here. We don't have time for fancy right now. So I'm gonna keep it pretty minimal. The full slides are online, but this is a more minimal version just to cover the basics. But, this will be recorded, and when I edit stuff, I'll add some additional examples. You know this meetup because you're here, but I also do one in Princeton. Princeton has just received a lot of funding through the university and the state to push Gen AI, and a new research topic just came out of Princeton on some advanced stuff they're doing. So we've got a multi-thousand person facility available for events, and I've got vector database people coming. I've got some big names in Gen AI coming. They're going to have some pretty interesting events there. We'll also be developing apps for nonprofits. So if you work with a nonprofit, definitely reach out. First event is like the second week in March. Every week, a couple people ask me, where do I find out about all this weird stuff coming out? I put it in my newsletter, and there are cat pictures there too, so it's not all bad. And that's, you could either read it in GitHub, I put in Medium, there's like 50,000 places. And this cat does have a very big mouth and can eat an entire Flink cluster. He's a big man. So as you see, our friends, the squirrels over here, are a very important partner that we're adding to our Flink area. And I'll show you the other side of the Flink puzzle. This is something we couldn't do before, except for a handful of companies who could write some seriously difficult Java and Scala code. I've seen maybe 10 successful projects, and those were some of the best minds in the country working on it. This new tool makes it a lot easier. So that's why we're all in on these guys. But there are other ways to do SQL to make it for certain use cases, not these super advanced use cases, but for regular analytics use cases, things where you just want to join some data, potentially be the data source that feeds the squirrel. You know, we get the raw data and, you know, the cat's feeding the squirrel. It's unusual, but it happens. Yeah, we get NiFi, loading data into Kafka topics. Then we get it to our Flink SQL, which can join them together, push them into other topics or other sources that they could read. And I'll show you quickly how our Flink SQL tool works. What's nice is it's very rich SQL. You don't have to use a limited version. It is powered by Calcite, so you could do things like group by, having, all those sort of things joined together, live SQL, and connectors for things like big data streams, S3, Iceberg, relational databases. And what's nice is we can also use things that NiFi feeds into Kafka for us. Or if we have some Pulsar people in here, Pulsar as well. And we can interact directly with Iceberg tables, which is the standard for Snowflake, for Cloudera, for a number of other people going forward, as it is a really cool format for storing data because it supports time travel, supports partitioning, and it runs on pretty much any platform. Got it running on my laptop. This is an example of creating a table against a PostgreSQL CDC. So I could do a SQL select against a database table as it changes. So this will feed me every event that happens from Postgres as a new change happens. So any CRUD, so creation, an update, insert, a delete, will all get messages for them, and I could do SQL on them and then push it into Kafka or clean it up, push it to a stream that could be worked on by someone with an app. But here you could take people who know your regular SQL, know things like Oracle PL SQL, and develop, you know, the start of a streaming analytics application or some basic streams, you know, really simple stuff, but, you know, some of it's pretty powerful. And that can be part of a very large stream of application where we can, if you were at the event at AI Camp, I showed you how we could connect to a bunch of different LLMs as part of that ingest process. So I can connect to Slack, get a feed of data, run it through some pre-processing, put it into a Kafka topic, and then make it available to whoever might need it. Again, putting the more advanced applications where they need to be. And now it's nice, you don't have to handwrite really complex code, which slows people down. This is a QR code. I don't remember where it goes. I might be getting $1. It just goes to a GitHub. Sorry. No money for me. There's a lot of events coming up. Next month, we're here. I'm trying to think what to do. I think I have a projector. Maybe we go in the other room. I don't know. Pinot people are going to be here. And we're going to do, if you haven't seen Apache Pinot, it's a pretty interesting database. And we'll do some stuff. Comp 42 conference is tomorrow. In a couple weeks, I'm doing the Gen AI one in Princeton, doing a nuclear summit, some other stuff. But let's show you the demo really quick. Now we have to get data. So I use NiFi to get data from a lot of different sources. Also Python to get some data. We get data into a stream. If you're here at the other event, just calling, I found I could run Olama, which is a local model, and it lets me download the full Mistral model, run it on my laptop, and then run it through a REST interface. It runs pretty quickly, but to me, the more interesting part is the data is actually decent. So when I get that data back, I have it posted into a Slack channel. So NiFi acts as a nice interface to and from Slack dynamically, which is a nice way to feed queries into your application. And I could push this right into Kafka or do some pre-processing. Here, I just pushed it through the local LLM model. And the other thing I do is I have another stream because I push this data into Kafka. So I have multiple applications receiving that Kafka. So your app can receive it. I've got one in NiFi that just calls a local LLM or the Cloudera ones. And I've got another one that reads the real-time stock quote. So again, why ask for a stock quote from a language model? It's going to either tell me it doesn't know or lie. So I'll hit the REST endpoint instead and get the current value. That's one of the things to do is some basic NLP to see what's going on in the system. But let's show you an example query. This is the interface for doing SQL analytics with Flink. This one is against Kafka. This is those stocks I was sending in. And this is just doing max and min. The nice thing with this is, and any Flink, I could change where I want to reach to into Flink. By default, you look at the current value in Flink in Kafka, but I could go back to the first available in my topics, which if you have a big enough system could be billions of rows. Depends how long you want to keep your data in Kafka. There's a big debate there. Most people like to keep a couple of weeks. Some people keep I have a company that puts so much data in, they can only keep it an hour because it's a petabyte an hour. And it costs too much money to put it more than that, which is kind of crazy. But yeah, what's nice is I could hit the earliest records available. And I do this with this other query that's not finance, but it's kind of interesting. Let me make this a little bigger because the query is kind of crazy. Reminds me of back when I was in Oracle. So I'm joining 3 Kafka topics together, but I don't have an exact match on how to join them because it's location. I can use this to put a distance, and there's lat long fuzzy distance, but I'm like, let me just do the dumb way because it makes it even worse looking SQL, is I'm putting a plus or minus on the lat longs and then doing full outer joins between 3 Kafka topics and just grabbing the fields I want. What I'm connecting is the MTA speed traps, which is the live speed cameras, with Transcom is a data feed from the 3 states in the area that monitor every road. So all their alerts, plus I've got the MTA bus information. So I've got 3 live streams I'm joining together. But if you look here, I'm looking at the oldest data I have in Kafka. That way I always get some data back. Otherwise, sometimes the buses aren't running, which is bad if you want to get on that bus. But the other thing we do is kind of interesting is once I have a query I like and I have it running in Flink, I can create a materialized view. And this is how I could share that with people who don't want to write to Kafka. So it is just a REST endpoint that returns back JSON if we got anything there, which would be better if we did have something there. It's still loading because I've got to get this running. I think I wiped out those tables. But if you look, when we get that data back, if we look, I could see the jobs running inside of Flink. So you could see all the craziness that you didn't have to build, which if your stuff is it's nice to use SQL. Obviously, I can't do much application level stuff at this point, but getting this data to this point and an aggregate and cleaned up, obviously someone can write code on top of that to make decisions like don't get on the bus. There's I can look up, do a window, look ahead and see that there's some buses that are not coming through in the next 10 minutes, or there's some road closed based on some of that other data, or looking at the speed cams that the speed has dropped significantly on the next 5 roads. Doing that predictive part, I'll give you that combined data so you don't have to try to do that yourself. One data stream, next part, build your app on it. Use some LLM to do some predictions on that as well. And you've got a pretty interesting application. Just an example of what you can do. It's pretty straightforward. And what's nice is once it's in a materialized view, I can take that and I can push it into a dashboard and do whatever I want with it. That's just what I wanted to show you. We don't have too much time. We'll do some questions. Well, what happens is, yeah, they get updated. I could start all these streams. I have like so many streams to get this going though, because I need to get 3 streams of data going. Because they got, where is all this data? There's, here we go. The New York 511 data is the bus data. Let's get the speed one going. And then we got to look at all the other data streams to get this going. I would leave them running, but I'm not made of money here, as you can see with the pizza here. And there is that was it. So please enjoy the pizza. Bring it back next time. Yeah, here's the Transcom. This one you got to sign up with the government organization to get it, but they give it to you in the lovely format of RSS. Who wants to do that? So NiFi converts it into JSON for me, because I don't want to do with RSS. I don't know if you like RSS, but I don't like RSS. Okay. NiFi's too fast for the demo, so I put something in there to slow it down. Otherwise, we don't get that data. We get the data 1,000 rows a second, and that's not a good demo. Let's see if we start getting data down here. Oh, wait a minute. I didn't start the bus. Got to start the bus. Let's stop this guy. The buses are really late, which you might want to tell people they could use Uber or something else. I break something in here. Trying to code like this is not the easiest. Oh, let's see. We only got a couple minutes left, but let's get in there. That's still running. Oh, interesting. I thought I stopped that. Okay. I was in a phantom screen there. So yeah, it's still running, but now this should be stopped. Some phantom jobs running on the cluster. I could just kill that. I'm sure that's safe. Again, I don't have security running on my Dockerized cluster here, which you should be running security. So we got the speed data coming in. We probably don't need me in there. Okay. Okay. Oh, there's the records waiting to come in. So hopefully if we get some of this data coming through, we will start seeing it. Did I start the bus? I don't think I started the bus. Too much data. I think we're running out of time here. Should have started it up before, but you know, or do we want to see the live cameras? No, we don't want to see live cameras. We're going to do the buses. We could find the buses. Unfortunately, they have a lot of data. So I like to grab all the data. There's all their haze cameras. There's their 501 cameras. No, that's their other data feed. How about this one? Alerts? No. Message signs. Why don't we put in bus? You would think I'd only have one level of buses, and you'd probably be wrong. There's actually, I also grabbed the buses from other parts of the world I don't know why, but it sounded cool when I could get them. So I did that. I think we're gonna give up on the buses. Sorry, buses. So we didn't get our live stream and it did not cache. Unfortunately, I had shut off my Docker, so I lost that stream. But we'll get back and see if there's any questions. We got a couple minutes left here. And I'll leave you on some useful links there.
Real time, I can see that all the speed cameras.
You get the speed at every location. The cameras update not as a camera stream. It'd be nice to be able to get the RTSC stream, but it is a 1 picture a second stream. So you can gather, I think there's 100 in New York, in Manhattan. You can gather those pictures, which, yeah, is pretty easy actually. Yes. Some of the cameras require you fill out a form to say you're not going to do something nefarious. Fortunately, I have done some projects for the some organizations, so they don't question me using this data. Yeah, this is all the cameras in New York. 1,800. Ooh. So that's a lot. At some point, they'll get mad at me for calling several thousand cameras at a time. I learned never call more than a few thousand. We shouldn't run an LLM on each one either. I'm storing that in Mini. Okay, here it is going to Slack. Let's see, do we get any through? We got a couple going back to Slack. So if we look down into Slack, they're all at different angles. So some are up close so you could read a license plate, and I could filter that through a plate reader and then figure out where you are and track you like Batman. I've been working on the Batman app, but people tell me not to show that in public. But it's extremely easy to write that. And you add LLM to that, I can predict where you're going to be based on the data from yesterday. And then I could put up a fake alert that goes to your, well, we won't even go to that. You don't need to know that. And if you've got a car that's not secure, we could tell it that it needs to stop, yeah. Make sure you update all the security software on your car. Reboot your car often. I don't know. Any questions? Just NiFi for this lab, for this cameras, or are you interested in the Flink one with joining the speed and the other ones? This one, for the cameras, it's just NiFi because I'm not doing any analytics on those pictures. But I can, because I could pull out some features, push that into a Kafka topic, feed that into an app, and he could start doing some real apps. And I could use that to feed some of those other questions like, okay, do you want to go to the bank? You need to go to the bank because you have a more in-depth question. I could tell you don't go to the bank in these locations, there's traffic. Or it's raining, I got weather feed. Or the subway is delayed, don't go to this one. I can give you direct directions and how to do it. Even call you an Uber or a taxi and then send you to the bank and maybe pay for it if you have a big enough problem. Maybe you're over 50 or 60 and you don't want to call someone on the phone. We'll send a car to pick you up and take you to the nearest bank.
You said the Batman use case, right?
Batman use case, and we stopped Bane just like that.
So then why do you keep Flink?
For analytics and for apps. NiFi does ingest. If you want to just do ingest, just do NiFi. If you want to do simple apps or, single user apps, do it with Python. You can do PyFlink, but again, it's not much easier than Scala, Flink, or Java, and they don't give you any kind of extra framework. You're handwriting all the stuff in the world.
I can't just have a NiFi connector with like pandas code in it.
You can, but I rather run pandas through Dask and have a cluster. Now, if you're thinking in the small, like you have just a handful of records, yeah, run it all on Docker and have NiFi call one Python program. But if you need to scale up or do an enterprise, like if I'm doing a real-time chat for a bank, I could have 10,000 concurrent users like the bank I worked with in Brazil. There could be thousands of people, especially during prime time. I'm not trusting Python that I spin up to handle that workload. Because here I could do, if once I get it to Kafka, I could distribute it to multiple apps. These can be clustered, and the clusters can be dynamically scaled with Kubernetes. So if I need to temporarily go up to 1,000 nodes, like Flink scales and Kafka scale up massive petabytes, thousands of nodes.
So like this upper medium level of scaling,
Yeah.
all 9.5 and you need to.
9.5 does the stuff that would be foolish to handwrite. Like if to read a camera in code, why write all that code? It's one line in 9.5. Or reading data feeds that change constantly. Why write the code out? Because you got to know every field. I don't care what the fields are. I could dynamically figure them out or get it from a schema. I can even grab schemas from Postgres tables and map that onto live streams of data. Even if it's a log file comes in and I'll grab a schema from a Postgres table, match them up, convert the fields and types, push that into Kafka, and then have an app read it. And you can write apps in other stuff. I mean, you can write them in Rust and you can write them in, C and Java, but this is a game changer because there's not much. The Flink apps themselves are hard. Like I have not written many Flink apps. It's not easy.
Trying to change that, but yeah. Right now it's hard.
Try to find a consultant. I hope you got a lot of money. It's not as much as a Gen AI person, and it isn't free. Any other questions? Everyone gets a free pizza. Look under your desk. The easiest way is through Kafka. Kafka, all roads lead to Kafka. It is the simplest way, the most scalable way. It is the most optimum highway or Pulsar. I mean, it could do it through S3. I could do it through Files or Iceberg, but Kafka's fast. Everyone has it. Now, there is an API in NiFi, so Flink can directly connect to me, but it doesn't make sense. There's no reason not to use Kafka, because in case you decide to change, who's going to get it? Like if you decide you need someone else to consume that data, add them as a consumer. It doesn't change him, doesn't change the producer. That's very helpful. I think we could wrap it up. Let me check the stream here. Sorry, guys. I forget about you guys. You didn't eat any of my pizza. Oh, that's Michael Coase. He's one of the Cloudera guys working on our cloud NiFi. So if you think this is too hard, we have things to make it easier. There's ways you can, we have pre-built flows, so you don't have to write some of this massive steps of code here. You just grab a button that says, I want Iceberg to Snowflake, press a button, deploy. A little easier. I guess that's it. Thanks for coming. Next month is with Pino, but definitely talk with these guys. This is cool stuff. And we'll hopefully put out a linked article, maybe some more examples on that API rag stuff. Very cool. Thanks for everybody coming out. We'll see you next month.